Okay, everybody. Tuesday, November 17th, and we're near the end of Chapter 8. Any questions, concerns? I sent out an announcement earlier. I apologize. It's Tuesday. I usually send it Monday or Sunday. Anyways, we can talk about that after. So we're near the end of Chapter 8. And we're going to talk about selecting an appropriate sample size. Obviously, if you're constrained, it makes it more difficult. But if in a theoretical perspective, you can certainly select an appropriate sample size for whatever you're measuring. So before you calculate a sample size, you need to determine a few things about the target population and the sample you need. So the population size, how many total people fit into your demographic if you're going to do a survey or you're going to use human subjects for your study. So for instance, if you want to know about mothers living in Canada, your population size would be the total number of mothers living in Canada. Not all population sizes need to be this large. Even if your population size is small, just know who fits into your demographics. That is very important. Okay, if you're going to use people as part of your measurement. Don't worry if you're unsure about the exact number. It is common for the population to be unknown or approximated between two educated guesses. The margin of error, your confidence interval, what we talked about. Obviously, no sample can be perfect, so you must decide how much error to allow. The confidence interval determines how much higher or lower than the population mean you are willing to let your sample mean fall. If you've ever seen a political poll, we talked a little bit about this on the news, you've seen a confidence interval. So for example, it will look like this. 68% of the voters say yes to Proposition Z with a margin of error of plus or minus 5%. Okay, and if you remember that, the 5% is your margin of error. And can someone tell me what happens if you start increasing that margin of error? No one? Brenda? What happens to the margin of error if you increase it? You can write your answer. Come on, everybody. I don't want to be doing a monologue. You can type in your answer. Anybody in the group? No one? John, you don't know. Okay. Brenda, do you have an answer? Do you know or you don't know what happens? No, sorry. Does anybody know? Noah, Roshani, Samar, Wellington. What happens if you increase that margin of error? We talked about it. Okay, you must have, lots of you must have very poor short-term memories. You increase the margin of error, your data becomes faulty because what you're doing is you're allowing to have false positives in your data or even false negatives. Okay? So please, people, look at this in your textbooks. Look at it on the PowerPoints. It's very important. All right. Your confidence level. How confident do you want to be that the actual mean falls within your confidence interval? The most common confidence intervals are 90% no, 95% confident, and 99% confident. Okay, and why do I say no for 90%? I just talked about margin of error. What happens if your confidence level is at 90% confidence? What's going to happen? No one has an answer. You're increasing the error. You're increasing your margin of error, which means you're going to have false positives or false negatives. And it makes your data faulty and not accurate. Okay? So, when you're doing a proper test, you want to have 95 or 99% confidence levels. Okay? The standard deviation. How much variance do you expect in your responses? Since we haven't actually administered a survey yet, the safe decision is to use 0.5. This is the most forgiving number and ensures that your sample will be large enough. Okay? What you want is your standard deviation to be between 0 and 0.5. Okay? That corresponds to the 95% confidence. It corresponds. It's not directly related, but it does correspond. So if anybody has any questions, please either write it out or say something. So, how confident do you want to be that the actual mean falls within your confidence? And as said previously, 90%. Usually use 90% for an exploratory study. It's the first time you're doing a study, so you want to see what the initial results are. You don't base decisions on 90%. You base if you're going to go ahead or you're not going to go ahead with whatever you're measuring. Okay, if somebody's building, a manufacturer's building a new car and they have a 90% confidence level, okay, so you're going to produce some what are referred to as beta models. They're not roadworthy. You're going to test them at all kinds of things, you know, braking, handling, acceleration, deacceleration, and see what happens. So you want to get a little more, you want to get a little more of the car, but you can see more of the faults. They're not actually meant for production. And we talked about the standard deviation. Okay, so the necessary sample size equals the z-score squared times the standard deviation times 1 minus the standard deviation divided by the margin of error squared. So here is an example of how the math works, assuming you choose a 95% confidence level, 0.5 standard deviation, and a margin of error of plus or minus 5%. Sorry. So you have 1.96, which is equivalent to the standard deviation squared, times 0.5 multiplied by 0.5, which is 1 minus the standard deviation, divided by the margin of error, 0.05 squared. And we end up with 3.8416 times 0.25 divided by 0.0025. And simplifying, we have 0.9604 divided by 0.0025. And we have 384.16 respondents. We're going to round down, so we should round down. It should be 384. They rounded up to 385. Okay, any questions about that? Finding the sample size. So for this particular study, They want to have 384 in their case, they're saying 385. If you find your sample size is too large to handle, try slightly decreasing your confidence level, but not by much, or increasing your margin of error. Again, not by much. And as I explained, this will increase the chance for error in your sampling. It can greatly decrease the number of responses you need. So you're sacrificing one for the other. If you can't get a hold, and if you're talking about human subjects or human participants in your study, if you cannot access that number of people, then you're going to play with the numbers, your confidence level, or your error, your margin of error. Any questions about that? No questions? Okay. So what way can someone think of a way where you can get 384 subjects relatively easily? What are we all using right now? Correct, Wellington. Yes, a survey, but on the internet. Okay, so you could send out a survey on the net to, you could just find I believe the phone book is an electronic version, or you can just randomly pick this by random number generator, and you can send out a survey to 1,000 people, or 10,000, whatever you want to do. And even if you get a 10% response, 1,000 is 100 people. Out of 5,000 is 500 people. So you can do that on the internet much more easily than previously when people were doing surveys. And it's pretty easy. Now, we're not going to talk about survey design, but there's a whole science to creating surveys that actually work well. So I'm going to show you a short video on sample sizes. So I just have to go to all right.
In this slideshow, I'm going to talk about sample sizes, and always an equation to use. So in this case, the equation is n is equal to, which is our sample size, 1.96 squared, which is a 95% confidence, times the standard deviation squared, which is sigma squared there, times the error rate squared, which is represented by capital E.
Okay, it's relatively very simple formula. Your sample size is your unknown. You know what the confidence level is, 1.96 squared times the standard deviation. Okay, and your error rate, which you know. All right.
So I'm going to do two problems in this case. I'm going to do them side by side. The first problem we're going to do, we're going to assume the standard deviation is 20 and the error rate is 4. And the second problem we're going to do is the standard deviation 25 and the error rate is 4. This will give you an opportunity to see how much a small change in the standard deviation impacts sample size. We start plugging and chugging and multiplying. So in this case, 1.96 squared is equal to 3.84, which is equal to 3.84 times 400 divided by 16. 400 divided by 16 is 25, so we have 3.84 times 25, which is equal to 96. And that's our sample size. Now let's redo the same problem again, but this time we'll use 25 as the standard deviation. We plug in the same numbers in the same spots. So we now have 3.84 times 625 divided by 16, which is equal to 3.84 times 39, which gives us a sample size of 96. Now, when we look at the standard deviations going from 20 to 25, and we compare that with the increase in sample size, we see that the sample size went up a lot more than the standard deviation did. So let me make a little graph of this as well. So we can see as the standard deviation increases, the sample size goes up more. So as an example, let's look at a standard deviation of 15. The actual sample size is 54. If we double the standard deviation to 30, we get a sample size of 216. This means that the standard deviation impacts the sample size a lot, obviously, right? And that's the whole point.
Okay, so I just want to add, if you look at this, it's an exponential graph. So exponentially it's going to go up. And again, what is the standard deviation measuring? Anyone? And you should know what this is. What does the standard deviation measure? I better go back and mark all your papers again, since nobody is responding about what a standard deviation is. No one can tell me what a standard deviation is?
Maybe it is a difference between observation of the observations means.
Yeah, well, okay, Song has written it out. It's the dispersion of the value away from the mean, okay? It's how much dispersion is occurring. What you don't want is you don't want a large dispersion, okay? You want something closer and usually under 1, okay? Or around 1, maybe 1.25 or something like that. Because if you have greater dispersion, what the graph is showing is you're going to have a very large sample. The difference between a standard deviation of 15 to 30 is the difference between 54 and 216 subjects. Okay, so I want you to understand that. Is there any questions about that? Okay, so let's go back to the PowerPoint. Okay. So, continue your sample size. There are 3 factors determining the size of a sample, none of which have any direct relationship to the size of the population. The level of the confidence desired, and as I said, usually if it's a study that has never been done before, or you're measuring something nobody has done before, you can sort of start at 90%. But the usual is 95. If it's something that's been done, 1,000 times before, or many times before, you may want to have 99%. Because you're basically replicating a study, but you may be looking for some factor that hasn't been discussed previously. The margin of error the researcher will tolerate, as I said, you don't want to go close to 1, or sorry, 10%. Okay, you want to be closer to 5%, and the variation in the population being studied. Okay, and the formula, N is the size sample, Z is the standard normal value corresponding, sigma is the population standard deviation, E is the maximum allowable error. So in this example, we have A student in public administration wants to determine the mean about members of city councils in large cities earn per month as remuneration for being a council member. The error in estimating the mean is to be less than $100 with a 95% level of confidence. The student found a report by the Department of Labor, that's American, that estimated the standard deviation to be $1,000. So what is the required sample size? So in this formula, E, the maximum allowable error is $100. The value of Z for a 95% level of confidence is 1.96. The estimate of the standard deviation is $1,000. We plug the numbers in. We have 1.96 times 1,000 divided by 100, all this squared. We end up with, and again, it's the same number. 19.6 squared is 384.16, and they round it off to 385. Well, I'm not going to give them full marks for that because it should be 384 or maybe 385 sounds good. Are there any questions about doing this, finding the appropriate sample size? If you're going to get a problem with this, you're going to get this information, okay? Basically, what you have to find is the N. What's your sample size? No questions about that? Okay. All right. So, sample size for estimating a population proportion. I'm just checking something. All right. Okay. So the formula is N, the size of the sample, Z, again, the same standard normal value, the corresponding to the desired level of confidence, E is the maximum allowable error. And P, the proportion, is P times 1 minus P, okay? And this is important. Use P equals 0.5 if no initial information on the probability of success is available. Okay, just use that. The same as if you're using the standard deviation as 0.5 and you don't know what it is. So in this example, the American Kennel Club wanted to estimate the proportion of children that have a dog as a pet. If the club wanted the estimate to be within 3% of the population proportion, how many children would they need to contact? Assume a 95% level of confidence and that the club estimated that 30% of the children have a dog as a pet. So following the formula and plugging in the values, we have N equals 0.3 times 0.7, our probability, times 1.96, okay, our Z, divided by 0.03, and all squared equals 897 people that should be contacted for the survey to see whether they have a pet or not, or they have a dog as a pet. The second example, a study needs to estimate the proportion of cities that have private refuse or garbage collectors, whatever word you'd like to use. The investigator wants the margin of error to be within 0.10 of the population proportion. The desired level of confidence is 90%, and no estimate is available for the population proportion. And what is the required sample size? Okay, so we follow the formula here. N equals 0.5 times 1 minus 0.5 times 1.65 over 0.1 squared. All right, that's within 10%, equals 68.06. Again, they round it up, and it's 69 cities. Okay, Is there any question about that? Finding the sample size, estimating a population proportion. And these formulas, you have them, okay? Any questions about finding a sample size for estimating a population or selecting an appropriate sample size? Is there no questions about that? Okay. So what I want to show you next is a video that I've named Bad Statistics. And in general, this is about every aspect of doing a study or doing an experiment. Anyways. Oops, sorry. Okay.
Now, I'm going to be talking about statistics today. If that makes you immediately feel a little bit wary, that's okay. That doesn't make you some kind of crazy conspiracy theorist. It makes you skeptical. And when it comes to numbers, especially now, you should be skeptical. But you should also be able to tell which numbers are reliable and which ones aren't. So today I want to try to give you some tools to be able to do that. Before I do, I just want to clarify which numbers I'm talking about here. I'm not talking about claims like 9 out of 10 women would recommend this anti-aging cream. I think a lot of us have always rolled our eyes at numbers like that. What's different now is that people are questioning statistics like the US unemployment rate is 5%. What makes this claim different is that it doesn't come from a private company, it comes from the government. And actually now, about 4 out of 10 Americans distrust the economic data that gets reported by government. Among supporters of President Trump, it's even higher. It's about 7 out of 10. Now, I don't need to tell anyone here that there are a lot of dividing lines in our society right now. And a lot of them start to make sense once you understand people's relationships with these government numbers. See, on the one hand, there are those who say that these statistics are crucial, that we need them to make sense of society as a whole in order to move beyond emotional anecdotes and measure progress in this subjective way. And then there are the others who say that these statistics are elitist, maybe even rigged. They don't make sense and they don't really reflect what's happening in people's everyday lives. Now, it kind of feels like that second group is winning the argument right now. We're living in a world of alternative facts where people don't find statistics this kind of common ground, this starting point for debate. This is a problem. There are actually moves in the US right now to get rid of some government statistics altogether. Right now, there's a bill in Congress about measuring racial inequality. The draft law says that government money should not be used to collect data on racial segregation. This is a total disaster. If we don't have this data, how can we observe this?
Okay, I'm just going to stop there. I'm going to ask a question. And I always ask this question when this topic comes up. Or maybe I should do, no, I will not do a poll. I'm going to ask everybody who's here, how many races are there in the world? Just pop up with a number. Okay, Song says 3. Anybody else?
Maybe 4.
Okay. Brenda, Brissa, John, Wellington says 4. Brenda says 4 with a question mark. Noah, Rajil, Samar. Noah says 6. Rajil says 5. Roshani, what do you say? 3. 4. Is that everybody? Roshani says question mark. Why do you have a question mark, Roshani? Remember, this is statistics class. You got to have a real number. You're not sure? Then take an educated guess. Okay, 4. All right. So have I got everybody? Brissa says 4. Okay. All right. So now I don't want you to be stunned or shocked, but I've done this in other classes. You know how many races there are in this world? 1, the human race, period. Okay? Your race is not determined by your color. There is no, and guess what? We're talking about statistics. And what I want to explain to you, and I did this in another class, is that what is the total difference in genetics between everyone on the planet? What's the margin of error between genetics of everyone on the planet? Can someone give me that error measure? You know, you can take a guess. No one? Remember, we just talked about error. Okay, Noah says 0.001. Anybody else? There is no or there's okay. I will tell you there is a difference genetically between everybody on the planet. But 001, that's interesting. Anybody else with a percentage? Nobody? Nobody wants to make a guess? 5% song? Okay. We are talking, you know, confidence levels. Amir Hossein says 3%. Anyone else? Okay, I'll call you Amir. Sorry, I didn't know whether you wanted that or not. Anybody else have a guess about the genetic differences between everyone on the planet? We're talking about confidence intervals. What's the confidence interval? Brenda says 1%. Think of the confidence intervals we just talked about. 1%, that's like a 99% confidence level. Okay, so the difference is approximately 5%, and that 5% can be explained basically, you're right, Song, exactly. Basically explained by geographical adaptation of our bodies to whatever our surroundings are. Okay. So what happened was, in the paper, these anthropologists went to an extremely remote island in the South Pacific because they wanted to see how different genetically were the people on this island who have really no contact with anybody except to buy things. And so the people on the island have lived there for, they estimated, between 5 and 10,000 years. So because of our belief system, we would think, oh my God, they must be totally different genetically than everybody else on the planet, right? Okay. So they did the genetic testing and they found that the maximum was 5% difference. Okay? That's a 95% confidence level. Okay? And the 5% was not statistically significant, which means we are all the same race. We are all the same people. Okay? Our differences are basically ethnically related. You know, our cultures, what we do, our color, which really has nothing to do with genetics. It has to do with our body's adaptation to where we are relative to the sun. If we're living close to the equator, we're going to be a little darker because our bodies are adapting to the infrared rays from the sun. People who are living on the extremes have a little less color because they're not getting as much sun. Okay, so I wanted to interrupt and I wanted to tell you And I don't know whether you've heard this before or not, but there is only one race on the planet. Okay. And the sooner people like realize that, but this has become part of a culture and people believe it. And I can go in the whole story. There was a Swedish botanist in the 18th century who came up with all the genus of plants and flowers. And I don't know who asked him or somebody commissioned him. Well, do all the people on the planet. And how did he measure them? By the color of their skin, which is ridiculous. He didn't have any genetics. He certainly did a pretty good job with the plants, but he used the information that he used on the plants for information on people, which if you're a good scientist or use proper scientific method and use proper statistics, it's ridiculous. Okay? So I just wanted to mention that to you. I don't know if people realize that before, but it is an interesting topic. So just when somebody asks you about races, there's no such thing. There's only one race.
Discrimination, let alone fix it. In other words, how can a government create fair policies if they can't measure current levels of unfairness? And this isn't just about discrimination, it's everything. Think about how can we legislate on healthcare if we don't have good data on health or poverty? How can we have a public debate about immigration if we can't all at least agree on how many people are entering and leaving the country? Statistics come from the state, that's why they got their name. And the point was to better measure the population in order to better serve it. So we need these government numbers, but we also have to move beyond either blindly accepting or blindly rejecting them. We need to learn the skills to be able to spot bad statistics now. I started to learn some of these when I was working in a statistical department that's part of the United Nations. And our job was to find out how many Iraqis had been forced from their homes as a result of the war and what they needed. It was really important work, but it was also incredibly difficult. Every single day, we were making decisions that affected the accuracy of our numbers. Decisions like which parts of the country we should go to, who we should speak to, which questions we should ask. And I started to feel really disillusioned with our work because we thought we were doing a really good job. But the one group of people who could really tell us were the Iraqis, and they rarely got a chance to find our analysis, let alone question it. So I started to feel really determined that the one way to make numbers more accurate is to have as many people as possible be able to question them. So I became a data journalist, and my job is finding these data sets and kind of sharing them with the public. And anyone can do this. You don't have to be a geek or a nerd. You can ignore those words. They're used by people who are trying to say they're smart while pretending they're humble. Absolutely anyone can do this. So I want to give you guys 3 questions that will help you be able to spot some bad statistics. So question number 1 is, can you see uncertainty? Now, one of the things that's really changed people's relationship with numbers, and in fact, even their trust in the media, has been the use of political polls. Now, I personally have a lot of issues with political polls because I think that the role of journalists is actually to report the facts and not attempt to predict them, especially when those predictions can actually damage democracy by signalling to people, don't bother to vote for that guy, he doesn't have a chance. Anyway, let's set that aside for now and talk about the accuracy of this endeavour. So based on national elections in the UK, Italy, Israel, and of course the most recent US presidential election, using polls to predict electoral outcomes is about as accurate as using the moon to predict hospital admissions. No, seriously, I used actual data from an academic study to draw this. There are a lot of reasons why polling has become so inaccurate. Our societies have become really diverse, which makes it very difficult for pollsters to get a really nice representative sample of the population for their polls. People are really reluctant to answer their phones to pollsters, and also, shockingly enough, people might lie. But you wouldn't necessarily know that to look at the media. For one thing, the probability of a Hillary Clinton win.
Okay, I'm just going to ask people, has anybody in the class been, or like sort of like within the last year, been contacted by any kind of polling company or pollster? No? No one? Does anyone? No? Oh, Brenda? Can you just sort of explain what they asked you? And you think, was it a valid poll? You know, what were they asking you?
Hi, so can you hear me?
I can hear you, yeah.
Yeah, so it's from Immigration, Refugees, and Citizenship Canada, because they
Oh, it was
do
from the government. Okay.
yeah, from the government. So because I believe they do some like a survey for example, like permanent residents, something like that, to see how we're doing in
Right.
Canada,
Yeah.
right? So yeah, I receive an email. I usually receive an email from them
Okay.
and sometimes mail.
Okay. And how many questions were there?
The last one that I did, it's a
Yeah.
lot
There was a
because
lot of questions.
yeah,
Okay. Mistake number one. You never survey with a lot of questions. Okay, we're not going to talk about, if you ever want to talk about survey design, we can talk about that. But that is one big mistake, because the person at the other end that's doing the survey goes, oh my God, this is going to take me hours. I don't want to do this. Okay, so what else? So there were a lot of questions. Do you think the questions um, were relative to the topic they were asking you about? It was, okay. And did they say it's just a loot? What's that? What is a loot? A lot. Okay. Okay. All right. And did they say it was going to be only seen by them? It wasn't for public consumption? Yes. Okay. Which they should do. All right. Confidential. Right. Okay. Did they send you the results? Why not? Did they explain that? Okay. Because what they should do is, they're not using anybody's name. They should send you a summary of the results, since you participated and you're a participant. Anyways, if people want to talk about a survey design, we can talk about that. Anyway, so we'll continue with the video.
Was communicated with decimal places. We don't use decimal places to describe the temperature. How on earth can predicting the behaviour of 230 million voters in this country be that precise? And then there were those sleek charts. See, a lot of data visualizations will overstate certainty, and it works. These charts can numb our brains to criticism. When you hear a statistic, you might feel skeptical. As soon as it's buried in a chart, it feels like some kind of objective science, and it's not. So I was trying to find ways to better communicate this to people, to show people the uncertainty in our numbers. And what I did was I started taking real data sets and turning them into hand-drawn visualizations so that people can see how imprecise the data is. So people can see that a human did this, that a human found the data and visualized it. So, for example, instead of finding out the probability of getting the flu in any given month, you can see the rough distribution of flu season. This is a bad chart to show in February. But it's also more responsible data visualization, because if you were to show the exact probabilities, maybe that would encourage people.
Okay, so her graph is funny, and I guess you know right away which month is the worst for getting the flu virus, right? It's February. Although it's kind of weird, because the zero, if you look here, the zero is at the top, and the number of times the maximum is down at the bottom, which you usually don't do graphs like. But I guess for emphasis point, that's what they're showing.
To get their flu jabs at the wrong time. Now, the point of these shaky lines is so that people remember these imprecisions, but also that they don't necessarily walk away with a specific number, but they can remember important facts. Facts like injustice and inequality leave a huge mark on our lives. Facts like Black Americans and Native Americans have shorter life expectancies than those of other races, and that isn't changing anytime soon. Facts like prisoners in the US can be kept in solitary confinement cells that are smaller than the size of an average parking space. Now, the point of these visualizations is also to remind people of some really important statistical concepts like averages. So let's say you hear a claim like the average swimming pool in the US contains 6.23 fecal accidents. Now, that doesn't mean that every single swimming pool in the country contains exactly 6.23 turds. So in order to show that, I went back to the original data, which comes from the CDC, who surveyed 47 swimming facilities. And I just spent one evening redistributing poop, so you can kind of see how misleading averages can be. Okay, so the second question that you guys should be asking yourselves to spot bad numbers is, can I see myself in the data? Now, this question is also about averages in a way, because part of the reason why people are so frustrated with these national statistics is they don't really tell the story of who's winning and who's losing from national policy. It's easy to understand why people are frustrated with these global averages when they don't match up with their personal experiences. So I really wanted to show people the way that data relates to their everyday lives. So I started this advice column called Dear Mona, where people would write to me with questions and concerns, and I would try to answer them with data. People really ask me anything, questions like, is it normal to sleep in a separate bed to my wife? Do people regret their tattoos? What does it mean to die of natural causes? And all of these questions are great because they really make you think about ways to find and communicate these numbers. If someone asks you how much P is a lot of P, which is a question that I got asked, you really want to make sure that the visualization makes sense to as many people as possible. Now, these numbers aren't unavailable. Sometimes they're just buried in the appendix of an academic study. And they're certainly not inscrutable. If you really wanted to test these numbers in urination volume, you could grab a bottle and try it out for yourself. The point of this isn't necessarily that every single data set has to relate specifically to you. I'm interested in how many women were issued fines in France for wearing the face veil or the niqab, even if I don't live in France or wear the face veil. See, the point of asking where you fit in is to get as much context as possible. It's about zooming out from one data point, like the unemployment rate is 5%, and seeing how it changes over time, or seeing how it changes by educational status. This is why your parents always wanted you to go to college. Or seeing how it varies by gender. Nowadays, male unemployment rate is higher than the female unemployment rate. Up until the early 80s, it was the other way around. See, this is the story of one of the biggest changes that's happened in American society. It's all there in that chart once you look beyond the averages. The axes are everything. Once you change the scale, you can change the story. Okay, so the third and final question that I want you guys to think about when you're looking at statistics is, how was the data collected? So far, I've only talked about the way that data is communicated, but the way it's collected matters just as much. And I know this is tough because methodologies can be opaque and actually kind of boring, but there are still some simple steps you can take like this. So I'll use one last example here. One poll found that 41% of Muslims in this country support jihad, which is obviously pretty scary, and it was reported everywhere in 2015. Now, when I want to pick a number like that, I'll start off by finding the original questionnaire. And it turns out that journalists who reported on that statistic ignored a question lower down on the survey that asked respondents how they defined jihad. And most of them defined it as Muslims' personal, peaceful struggle to be more religious. Only 16% defined it as violent holy war against unbelievers. Now, this is the really important point. Based on those numbers, it's totally possible that no one in the survey who defined it as violent holy war also said they support it. Those two groups might not overlap at all. It's also worth asking how the survey was carried out. This was something called an opt-in poll, which means that anyone could have found it on the internet and completed it. There's no way of knowing if those people really even identified as Muslim. And finally, there were 600 respondents in that poll. There are roughly 3 million Muslims in this country, according to Pew Research Centre. That means the poll spoke to roughly 1 in every 5,000 Muslims in this country. Now, this is one of the reasons why government statistics are often better than private statistics. A poll might speak to a couple hundred people, maybe 1,000, or if you're L'Oreal trying to sell your skincare products in 2005, then you spoke to 48 women to claim that they work.
Okay, so this just leads into what we were just talking about, having an appropriate sample size. And it's very, very, very important, obviously, depending on what you are trying to find, or if you're doing people, what you're trying to find, and who are the people that you're trying to contact. Because when you do a survey, you want to get the right appropriate demographic. If you're, I don't know whether I talked about this previously, if you're looking at, say, female CEOs in companies, are you going to interview male CEOs? Would that be appropriate? No. Why not? They're CEOs, aren't they? Don't you want their opinion about female CEOs? song? Right, Brenda. That is okay. You got it. And that's why I ask everybody. And really, really, when you're going to do, you know, you've got one more chapter test left, and you have the exam. Please read the questions carefully, and please figure out. And usually in a question, it's sort of the last sentence. It's asking you what it wants. Don't make up information. Don't give them what's referred to as extraneous information, something that has nothing to do with the question. You know, there's a question, it's a specific question. You want to find the specific answer to it. Okay? So you must please read the question carefully in, you know, whatever evaluation you're going to have. You know, even the case study, it asks if you're using the data from the website, it's asking you specific things to do. All right, that's very important. I can't emphasize it more.
See, private companies don't have a huge interest in getting the numbers right. They just need the right numbers. Government statisticians aren't like that. In theory, at least, they're totally impartial.
Okay, I'm going to stop one more. Is there anybody in the class that is in marketing or wants to go into marketing? Well, John, are you speaking for everybody in the class or yourself? Anybody in marketing? Okay. All right, Brenda, no, okay. And my second question is, obviously it looks like nobody is in marketing. Do you have to take any marketing courses? Okay, Amir, you don't know whether you have to. I don't know either. I'm not sure what but my point was, if you look at what she's talking about and what we've talked about in the class, in marketing, when marketing companies take on contracts for, you know, commercial companies and they're creating surveys, are they following all the procedures that we talked about in statistics in this course? I don't know. That's why I was curious if anybody was taking. Brenda, you're correct. They may not. And so who knows? The public doesn't know. The people participating in a survey may not know. And so when a company says, I don't know if people are old enough or they heard about this. When I was a kid, you know, these toothpaste companies would say, yeah, and 4 out of 5 dentists recommend Crest. Okay, well, what, they only surveyed 5 dentists and 4 of them said Crest? Well, there's a lot more dentists than 5 dentists because they are not obligated to release the results. And so I want you to be, you know, be wary when you hear about polls or you hear about, because it's not coming from the government. Because if you want government data, you can get government data. If you want a company's data, well, that's another thing. Okay, so just be wary when you hear about numbers or numbers related to statistics. You know, oh, this is the best car there is on the road. Oh, according to who? You know, there is a survey that was done in psychology where they found that what is everybody's favorite color? Can someone tell me? What do you think the most favorite color is of any color there is? blue, black, blue, blue, red, brown. Anybody else? Okay, Song, you did it again. It's red. Everybody loved red. Okay, it's just, when you hear things on the news or you see things on the net, that's why you have to be curious. Where's this info coming from? Don't just accept it. That's the important aspect of this. Well, let's finish this video up.
Not least because most of them do their jobs regardless of who's in power. They're civil servants. And to do their jobs properly, they don't just speak to a couple hundred people. Those unemployment numbers that I keep on referencing come from the Bureau of Labour Statistics. And to make their estimates, they speak to over 140,000 businesses in this country. Now, I get it, it's frustrating. If you want to test a statistic that comes from a private company, you can just buy the face cream for you and a bunch of friends, test it out, and if it doesn't work, you can say their numbers were wrong. But how do you question government statistics? Well, you just keep on checking everything. Find out how they collected the numbers. Find out if you're seeing everything on the chart that you need to see. But don't give up on the numbers altogether, because if you do, we'll be making public policy decisions in the dark, using nothing but private interests to guide us. Thank you.
Okay. Okay, so any comments? Any comments about the video? No comments about the video? All right. Okay. So technically we have completed the 8 chapters as part of this course. Okay. I don't hear any cheering. Okay. So this is what I'm going to do. On Friday, I'm just going to start the review of each of the chapters. And I would certainly like you to come to the class, because basically it's going to be, test questions and answers, and you can bring up whatever concepts that you're not clear about. And what I want you to be able to do is to, understand all the concepts that we're going to cover. So it's going to be, in the form of, I wouldn't say a quiz, it's more like, quiz questions and tests, and I want you to participate in this. I don't know whether everybody got my note that I sent earlier. Friday at 5, you'll have access to the Chapter 8 test. Okay, and again, it's available from Friday at 5 p.m. to Monday at 5 p.m. In addition, I sent out the homework assignment for Chapter 8, which you can do at any time, but it's due Monday at 5. All right. As well, what I'd like people to do is to, again, come with questions. We're going to start with Chapter 1 on Friday. I don't know if we'll get to Chapter 2. And after doing the review of all 8 chapters, we should be finished before the date for the exam. And I'm trying, does anybody remember what the date was for the exam? I can't remember. I don't remember whether it was December 16th or no, I can't remember. So what I'm going to ask the class is, Once we finish the review of all the chapters and everybody is satisfied with their understanding of the concepts, if you want to do the final exam earlier than what the date was that I had written down, or if you want to keep it the same date, but I'll ask that later on. And what I'm going to do is also, if people have, well, that's exactly what I was going to talk about, Brenda. Do you want to have a class that talks about the case study? Now, because people are doing different data sets, then what I'd like you to do, and we can do this at any time, is bring up the questions that you have about the particular data set that you're doing. Okay, and I hope everybody has looked at sort of the way that the case study should be written up. Okay, I don't know whether I talked about this. It shouldn't be more than 5 pages. Okay, and you're using the headings that were part of the research proposal. Now, if you've got a lot of graphs, that's fine. Okay, that's fine. But 5 pages of text, under the headings. So I don't know whether, is that clear for everybody? Okay, you're not writing 30 pages or 40 pages. But if you do want to produce graphs, and as been said before, picture's worth 1,000 words. But remember, when you're doing that, your graph has to be, somebody can look at it and go, oh, now I understand what you're trying to say. You don't want to make it complicated and you don't want to make it convoluted. But we can talk about that. So what I'd like you to do is this is, I'll just do this right now. So on Friday, what we can do is, let's say for 3/4 of the time, we'll do the review. And then for 1/4 of the time, if people have questions about the case study, then you can ask me about the case study. Amir, you're asking, do you need an appendix? No, you do not need an appendix. Okay, you need a bibliography. That's your resources. Okay. So we'll try to do that kind of time allocation, 3/4 for review, 1/4 for the case study. Again, I'm still going to have the office hours on Mondays and Wednesdays, and you can certainly pop in those and you can ask me whatever you want to ask me. All right. Okay, so I just want to make sure everybody understands the course is not finished. We're technically finished the content, but now we're going to do a review of the content. And I want you to pay attention to that, because since I've seen a lot of stuff, there may be some questions that we're going to talk about that are going to be on the exam. Okay, and the exam is going to be, a 2-hour allocation, the same as the test. So, is there any questions that anybody has about today or what we're going to do? Nobody has any questions? No? Noah, no questions? All right. Song, any questions? Ray Jill, any questions? Okay. All right. So since I'm not going to start doing the review now, unless you want me to start doing the review, we can end the class. So, okay, Amir, what does that mean? With 94.5% accuracy. Okay, I'm going to explain to you something. That's not very detailed, what you're saying. You're giving me like a half a sentence. Who has it been tested on? These are the questions you have to ask when you're doing stats. Has it been tested on anybody? And what do you mean by 94? Is what Moderna? What is Moderna? Sorry. Is what Moderna says. What is Moderna? I don't know. I'm not familiar with it. Is it a publication? Oh, it's a vaccine company. So they're saying they have 94.5% accuracy. Okay. Technically, and if you've tested everything, yes, it should be safe. But where's the data? Oh, it's the competitor for Pfizer. Okay. Yeah, remember, okay, I want everybody to remember something. These are two pharmaceutical companies. Okay? You watch the video. How would you say their data is valid? Has anybody seen this data? Or have they released it? Remember what the woman said in the video. If there's no validation and it's just coming out in the press and it's not been monitored by anybody, how do you know it's exactly 94.5%? Yeah, it's on the news, but it's news. Okay, that doesn't mean it's real. You know, Trump, fake news, right? They can say whatever they want to say, and they put it out on the public. Yeah, exactly, Brenda. You don't know. And are they going to release the data to the public? Will they do that? This is about money. Right, Song? No, because this is about money. These are two companies competing with each other. They want the medical profession to buy their vaccine, right? This is what it's about. This is not like, well, you know, some people die, some people die. No, you don't want anybody to die. All right? You know, and I don't know how strict they are in the States, but I think if somebody says we're ready to release a vaccine, it has to go to the Federal Drug and Administration before it actually can be released to the public. Okay? I don't know what they do and if they practice appropriate statistical behavior. This is not going to be released next week. So this is why I tell you, be wary when you see numbers like this. Okay? If it's not validated and it's within a particular company, we don't know what statistical methodology they're using to come up with that 94.5%. Right? That's the important thing. And hopefully that's what you understand about doing statistics and being wary. So are there any questions? So one other thing, what I'd like you to do is to, if anybody will do this chapter by chapter, if anybody has questions right now for chapter 1, any concepts within chapter 1, please bring them to class for Friday, and then we can discuss it. Okay? And again, as I said, so what we're going to do is we're going to do start with a review, starting with chapter 1. We're going to look at any questions that anybody has about chapter 1, any concepts that they don't understand. And 3, if you have any specific questions about your case study. And I just want to tell you that if I have the time, if you want to send me drafts of what you're doing, but you can follow the template and follow the examples that are on the website, and it should be fine. Okay. Is there anybody in the class that has not written a paper using APA standard? Okay, so if nobody says anything, that means everybody has written a paper using the APA format. Is that correct? Amir, did you use APA? Okay. If everybody has done APA, it's exactly the same. It's just the headings are different, right? You know, and the headings you have from the research proposal template. Okay, everybody knows how to do a bibliography, right? Okay. So, what do you mean you guessed, John? You don't know how to do a bibliography? You just said you did an APA paper. Either you know how to do it or you don't know how to do it. Not very much. Okay, look at it again. Okay, I'm going to mention something, and I don't know whether you mentioned in your other classes. You can write it down. It's called Purdue OWL. Purdue, one word, Purdue University. Okay, Purdue OWL, OWL. Okay, they have a massive website to do with formatting. And if you do get stuck and you're not sure how you want to do it, go to Purdue OWL, and they have examples and they show you how to write the paper appropriately. Okay, I don't know if people are familiar with that, but it's a very good site. It's an excellent site in terms of formatting papers. So, any questions? No questions? All right. Okay, Wellington says no. That must mean there's no questions. This is for people to get their data out of Blackboard? No. This is for anybody. You're writing a paper, it's got to be done in the appropriate manner, Amir. If you're not getting your data from Blackboard, you have to send me a copy of where I can see this data. Okay? And anybody else who has not given me where the data is coming from, I want to see the data. Okay? And I know there's some people here, there's some people that are not here that I have to contact because I have not received where the data is coming from, or the source, what's referred to as the source of the data. All right? Any more questions? No? Okay. All right, then I'll let everybody go. And again, I have office hours tomorrow from 10 to 12, and I will see you on Friday. And remember to bring whatever questions you have. Okay?